All right, this question says a 10 kilogram rock is dropped from a height of 10 meters onto a spring below. It says if the spring is known to have a spring constant of 100 newtons per meter, how far will the spring compress? So, there is an easier way to do this and a more difficult way to do this. And we are in this class more focused on the easier way to do it, but I will show you just a little bit of the more difficult way to do this just so that you have an idea of a more realistic solution. So we're going to start off with, we are trying to solve for how far the spring is compressed, which is our x value. We know that we can use conservation of energy. Since I know I have a spring and being dropped involved, I know I'm going to have potential energy due to gravity, and I'm going to have potential energy due to some sort of elastic situation. So here's basically what we have. You have a rock that's being dropped onto a spring, and you want to know how far that spring is actually compressed. Okay, the easy thing that we're going to do is we're going to say that when the rock drops to this point, all of its energy is converted into compressing the spring. So in other words, I'm going to say simply mgh is equal to 1/2 kx squared. Okay, and that's true for both situations, but I'm going to define this height right here as h, and then this right here as x. And it's actually a little bit more complicated than that, but let's go ahead and solve this and then we'll talk through some complications. So you are given a mass of 10 kilograms. If you notice in this particular example, we can't simply cancel out the mass because it's not on both sides. We have that it's dropped from a height of 10 meters. We also have that the spring constant is known to have a value of 100 newtons per meter. So really, that's all I need to know, because I know gravity is 9.8, and I can say 10 times 9.8 times 10 equals 1/2 100 x squared. And when you do that, we can go ahead and start to simplify. We have 980, which is 10 times 9.8 times 10, equals 50 x squared, 1/2 times 100. Divide both sides by 50, and you get 19.6 equals x squared. You can then take the square root of both sides, and you can say this is 4.43. Now, for the more difficult solution to this particular question, we're just going to talk through it real quick, and I can show you real quickly how you can solve it, is this. Really, the rock doesn't fall just this h. It actually falls h plus x, because the rock will continue to fall. Even when it touches the spring, it will keep going down until it's compressed a certain, till the limit of the spring. So really, this should actually be mg, and then I'm going to go ahead and plug in what h is, 10 plus the displacement of the spring. Now, the reason why we didn't solve this way is you can see that when you plug in your numbers, go ahead and plug the numbers in, it creates a problem. And that problem is you have x on this side and you have x squared over here, and then you're going to have some other number right here. What this sets up is it would set up a quadratic equation that you would have to solve. Now, it's not terribly more difficult than things we've already done, but it is a little bit further than we want to go in this class. Just be aware that this is a more accurate solution when you account for this than what we did in the previous solution.